then we can start. All right, so today we're going to continue with chapter 5. And what are we going to see today is a conservation of energy. But then now, what should we do if there is a frictional force or energy loss in the questions? Okay, so this question, it shows you clearly the difference between two different cases. One with energy loss and the other one without energy loss. All right, now let's go through the questions. A child with mass m rides on an irregular curved slide of a height h equals to 2 meters as shown in the figure. The child starts from rest at the top, okay, and then determine the speed at the bottoms and assuming no frictions presence. So initial, okay, what do we have at the initial? So initial, it tells us objects start at rest. Now, what does it mean at rest? It means u equals to 0. What does it mean by u equals to 0? It tells us k is equals to 0. Okay, and then we have h equals to 2 meter, in which it tells us our u is non-zero. Okay, our u is a non-zero value. And then what happens at the final? Now, determines the speed at the bottom. So bottom is here. So this is our final position. So final positions, now v is a non-zero value because it asks us to calculate. So which means k is also a non-zero value. And then how about height? Now height, again, most of the times we take the ground as our final, as our h equals to 0. So if h equals to 0, then u is also equals to 0. So that is the information that we have right now. Now let's see how are we going to solve questions A. Questions A, it asks you to assume no friction. Okay, no friction. So it means we can just apply a principle of conservation of energy. So summations E initial equals to summations E final. So the energy involved here, now since no spring, so we have just a U and K. So U initial plus K initial equals to U final plus K final, right? So U initial, well, U, since we say is a non-zero value, so I'm going to substitute as mgh initial. K is a 0 value, so cross it out, equals to U final, cross it out because it's 0, and then K final, 1 over 2 mv squared. Okay, now if you look at these questions, questions A, you don't have the mass yet, okay, because the assumption is for question B. But do you need mass in the first questions? Not really. Why? Because you can just cross out, okay, you can just cross out the m. So m, you don't need it. So by rearranging the equations, okay, you will get v equals to square root 2gh initial. Okay, plug in the value and then you're going to get a final answer, which is a 6.26 ms negative 1. Okay, so G is 9.81, H initial is 2 meter. That is what we know, right? Okay, now how about questions B? Okay, questions B now, it tells you there is a frictional force. So if there is a frictional force, then you can no longer use the equations in questions A. You need to modify it a little bit. Okay, you need to modify it a little bit. So now questions B, how am I going to change the equations? Since there's an energy loss, okay, because now there is a frictional force, so means there's an energy loss. So like the questions also mentioned, how much mechanical energy loss? Okay, how much is being lost? So summations E initial, now remember, because now you're looking at energy loss, so you need to add energy loss. Okay, so which means initial energy minus final energy loss, it will then give you a final energy. Oops. Yeah, it will then give you a summations E final. Okay, summations E final. So again, if you look at the equations, or you look at the stations given just now, initially our K is 0. Okay, and now when it reach the bottom, U is 0. These two, they remain the same. Okay, they remain the same. The only difference between case 1 and case 2 is that now there's a energy loss in the second case. So let us expand the equation first. Summations K as E initial, it is equals to U initial plus K initial. So plus with energy loss, okay, which is then equals to U final plus K final. According to our analyze just now, okay, K initial is 0, U final is 0. All right. So next, what are we going to do? We want to expand the equations. So mgh initial plus energy loss equals to 1 over 2 mv squared. Aha, now this one you can no longer cancel out the m. Why? Because now you have an E loss here. And E loss, it doesn't come with m. So that is the reasons why in questions B, okay, why in questions B, they give you m equals to 20 kg. And V final is now equals to 3 meter per second. So if you notice, V final now is less than the V in questions A. Okay, object, it becomes slower because of the frictional force. So frictional force causes my objects to move slower, therefore you have a lower final velocity. So remember, you don't use the V from questions A, you use the V given in the questions. Okay, assumes that your VF is 3 meter per second. So that is the values that we're going to use in questions B. So M is now 20 kg, and then 9.81, initial height 2 meter, plus energy loss, which is then equals to 1 over 2, 20 kg, and 3 square. Okay, don't use 6.26. So this is a very common sense mistake where students use the V from previous questions. All right. So energy loss is then equals to negative 302 joule. Okay, so it is a energy loss, so it must come with a negative. So if you calculate, you got a non-negative value, then that means there's something wrong in your calculations. All right, so this is the solutions for questions 4. I give you 2 minutes to write it down. Okay, and then go through it again, see what is the difference between with and without energy loss, frictional force. Okay, before we proceed to questions 5. So 2 minutes for you to write it down. If you got any questions, you may ask. Okay, so the question is very simple, just that you have to be careful when there's energy loss. So these questions just consider as introductions to questions with frictional force. Now let's try a more complicated questions. Okay, so I want you to try to extract the information first, to sketch a diagram first before I explain it to you. Okay, so 1 minute for you to sketch the diagram. You try to think, how are you going to answer these questions? Do you have enough information to answer these questions? Okay. So children and a slide with mass. So now it treat both children and slide as one object. Okay, and then the mass is 50 kg. They slide down a hill with height of 0.46 meter. So, okay, now you have a hill. I'm going to sketch a diagram here. So this is the hill, and then this is the ground, right? So it tells you now this height, okay, the height of this hill is now equals to 0.46 meter. Okay, so don't get a wrong idea. Okay, height, it means from ground to its current position. It doesn't mean displacement. All right, students often got it wrong because they thought this 0.46 is a displacement along this inclined surface, okay, which is incorrect. So if the sled is start from rest and has a speed of 2.6 meter per second at the bottom, so now what is the informations? The informations given, it tells you initially, this is your object. Your object initially is at rest, okay? And then the final velocity is equals to 2.6 meter per second. And then how much energy is lost? So again, it's the energy loss questions, all right? And then if the hill has an angles of 20 degree, so now you have a 20 degree here, and then it wants you to calculate how much energy lost, and then what is the frictional force. So there are two things you need to calculate, all right? One is a frictional force, and one is energy loss. So let us begin with energy loss. Okay, let us calculate energy loss first. Energy loss is very similar to what we just tried in questions 4. So now you have an object, okay, and this object contains two items, which is the children and the sled. All together is 50 kg. And then it experiences energy loss. Therefore, I'm going to use equations summations E initial plus E loss equals to summations E final. All right. So again, summations E initial. I'm looking at mechanical energy. Mechanical energy, there are 3 types of mechanical energy. In our case, we don't have spring. So again, we just ignore US, okay, the elastic potential energy. So what are we going to do now? Okay, so U initial plus K initial, okay, plus energy loss, which is then equals to U final plus K final. Okay, U final plus K final. And then what are we going to do? Expand the equations. Okay, but before that, if you want to make it simple, you can cancel the things that we don't have first. Okay, for instance, we don't have K initial. Why? Because it tells us U is equal to 0. Okay, and then we don't have a U final. Why? Because it's at the bottom. At the bottom, H is equal to 0. Okay, H is equal to 0. So this 0.46 is actually your H initial. Okay, H initial is equal to 0.46. So now I have the information that I want. Therefore, I'm going to expand the equation. mgh initial plus E loss equals to 1 over 2 mv squared. Okay, so plug in the value. So m given is 50 kg. And then 9.81, where H initial is 0.46, then plus E loss, okay, which is then equals to 1 over 2, 50, and then a 2.6 squared. Okay, 2.6 squared. So rearrange the equations. Energy loss is actually equals to 42 joule. Okay, you're going to get a negative 42. Negative 56 joule, sorry. Negative 56 joule. Okay, negative 56 joule. So if you calculate everything correctly, this is what you're going to get. All right. Next, what does it mean? How are we going to calculate frictional force? How do we calculate frictional force in this case, in these examples given? So if you want to calculate energy loss, okay, you look at the diagram first. Okay, try to recall energy loss is caused by what? It's caused by frictional force. Okay, so in this case, what are we going to calculate is actually the work done to overcome, okay, the work done to overcome the frictional force along the path traveled. So which means you have to take into consideration the directions of motion, which is the S. So object slides down an inclined surface. So this is our S, which is equals to, okay, now how to determine S? Do we have S in our questions now? Apparently no, right? So we need to determine S first. If you look at the diagram, we have a right angle triangle here. Okay, the right angle triangle, which show us this is a 20-degree, and then the opposite angle, the opposite length is 0.46 meter. So what we want to calculate now is the hypotenuse. So by using the trigo function, sine 20-degree is equals to 0.46 divided by S. Okay, where your S is now equals to 1.34 meters. So this is the displacement. Okay, now that you have displacement, you can then proceed to calculate the frictional force. All right. So E loss is actually your, okay, E loss is actually your W to overcome frictional force, which is then equals to, now, WF. What is WF? WF, if you recall the equations that we learned yesterday, is Fs cos theta. All right, Fs cos theta. So W, I have a negative 56 joule, okay, which is then equals to frictional force is the thing that I want to calculate. And then S is 1.34 cos theta. Now, cos theta, if you remember, what did I tell you yesterday? Frictional force is always opposite to the directions of motion. Therefore, our F and our S, they are always opposite to each other. So cos theta, even if you don't have the diagram, you should know that it is always 180 degree. Okay, because as we use the directions of a motion, and V is always opposed to the directions of motion. Therefore, the angle is always 180 degree even without the diagram. Okay, so now that I have everything here, rearrange the equations, I will get F equals to 42 Newton. Okay, F equals to 42.26 Newton. Okay, 42.26 Newton. Okay. So 42.26 Newton. All right. So this question now is a slightly more complicated. Why? Because it involves the calculations of frictional force. So again, I give you 2 minutes to write it down before we proceed to the last question, which is a question involve two objects in a system. Right? So 2 minutes for you to write it down, then we'll proceed to the last questions. Okay, so the difference between previous question and this question is down. Now this question, it got one additional step. So this is the things that you need to do. Okay, sometimes questions might give you frictional force, and then maybe it asks you to calculate final velocity. Then you need to know, okay, that you need to substitute this equation. Okay, you need to substitute these equations into here. Okay, in order to solve the questions. Okay, sometimes that is what you need to do, right? Okay. So far so good.
Yes, so good.
Okay, good. So now let's look at the questions number 6. Okay, the last questions that I'm going to discuss today. So once we are done with these questions, then I will let you guys go. Now, these questions is slightly more complicated. Why? Because it involves two objects. So the coefficients of the frictions between the 3 kg blocks and the surface is 0.4. Not only involve two objects, and now it also have energy loss. Okay, it also experience energy loss. The yellow color object, okay, I'm going to call it box, and then this one I'm going to call it ball. So if the system is start from rest and then calculate the speed of the 5 kg ball when it has fallen a distance of 1.5 meter. So now this question, it doesn't tells you whether this 1.5 meter is the distance between the ball and the ground or not. Okay, so you cannot assume it has reaches the ground. Okay, you cannot make the assumptions yet. So what are we going to do now? Let me re-sketch the diagram. Okay, so this is the initial position. This is the box. And then this is the pulley. And then this is the ball. So initial height, I'm going to take it as x. Okay, because I don't know what is the initial height. And then the final position, okay, the final position. So let's say now this one has moved a bit. So now my ball also moved a little bit. Okay, so I'm not sure whether it has reaches the ground or not. So I cannot assume it reaches the ground. Okay, it has reaches the ground. So what am I going to do? So the final position, because it tells you it moved by 1.5 meter, what I can do, I can just assume the final height is x minus 1.5. All right, so it becomes shorter. So initially it's x. So after it moved by 1.5 meters, so the distance between the floor and the ball, okay, becomes x minus 1.5. So again, ground is always h equals to 0. Okay, when it comes to these types of questions. So this is the ground. Okay, so this is the initial. This is the final. All right, so this is based on my sketching. So what am I going to do next? Okay, now I have two objects. Okay, I have two objects. Okay, rather than call it box and ball, I'm going to change the name. I'm going to call it number 1 and number 2. Okay, object 1 is the box, object 2 is the ball, to make it easier in our calculations. So what am I going to do next? Now we try to extract the information. Okay, so it tells you the block is a 3 kg. Okay, so block is 3 kg. And then ball is a 5 kg. Okay, ball is a 5 kg. Initially, object is start from rest. Okay, so your u initial is equals to 0. Okay, your u, velocity initial. And then it asks you to calculate v. So v final is how many? Okay, it's how much. All right, now we are going to try to solve it. So according to these questions, now it experienced frictional force. There is energy loss. Therefore, summations E initial plus E loss is equals to summations E final. Okay, summations E final. Summations E initial now. If you look at these questions, now that you have two items, two objects, okay, two objects in the system, means that you have to take into considerations the energy, okay, the energy inside both of them. All right, you cannot just use the U initial, K initial for just the ball or just for the block. You have to calculate the energy for both of them. All right, so what am I going to do now? I want to put a bracket here. K initial plus U initial, close the bracket, for the block. Okay, for the block, plus K initial plus U initial for the ball. Aha. Okay, and then plus energy loss equals to K final plus U final, close bracket, for the block, and then plus K final plus U final for the ball. So that is the things that you need to calculate when it involves more than one object. If there's another object, maybe the third object, then you need to add one more bracket, okay, and then calculate the energy for the third object. So once that you reach this step, you got this correct, then basically you are very close to the correct answer. Okay, the next thing is just that you need to think. Okay, you need to think what is the things that we have right now, what is the information that what is the information that we have right now, what is the things that we need to take into considerations in our calculation. Okay, so let's see. Okay, now if you look at the question, it tells you objects start from rest. If objects start from rest, it means K is equals to 0. So K initial for both of them, they are equals to 0. So you can cancel it out. Okay, you can cancel it out. And then what else can I remove from my equations? Now, if you look at these two diagrams, okay, object 1 and object 2 in the second diagram, the only things that involve in the change in height is the ball. All right, your object block is moving along the same surface, which means the height for object for the block, okay, the H initial and H final for the block is the same. All right, it's the same. So in that case, wait, I'm not going to call it H. It will make us confused. Okay, so I'm going to call it a capital letter H. Okay, so this X is our H initial. This one is our H final. So initially, the object is moving at a height, the block is moving at a height that is equals to capital letter H. And then after the ball has fallen 1.5 meter, the block is still at the same position. There's no change in height, means there's no change in the potential energy. Therefore, you can actually remove it. Okay, you can actually remove the potential energy for the block because it's just moving along the horizontal component. It doesn't involve the change in the vertical height. So there's no change in the potential energy in the box. All right. Okay, now, okay, how about all the other things? So initially, the ball come with a height. So yes, I need to keep it. Object move with a final velocity. So I need to keep the K. I need to keep the K. And then I need to keep the final U for the ball. Okay, because it has a final H. Okay, it has a final H. All right, now next, what am I going to do? I'm going to expand the equations. So a ball is a M2 GH initial, or you can write M ball. Okay, it's up to you. Plus energy loss. Okay, do we have any information about energy loss? No, but what we do have is just a coefficient of friction, which is 0.4. Aha. So in that case, I might need to expand my equations a little bit. Okay, because now the information given is coefficients of friction. So we cannot just leave it in terms of E loss. Okay, we have mu equals to 0.4. So when to use mu is when we have F. Okay, so F as cos theta equals to K for the object block. So 1 over 2 M1 V square. Now, I don't have to use subscript for V. Why? Because now block and ball, they are being attached by the same string. So which means both of them, they're going to move with the same velocity. Okay, and then plus 1 over 2 m2v square plus m. Now this one again belongs to ball, so mg h final. Okay, mg h final. But then if you look at my equations, okay, it still has there's still no equations, no informations involve coefficients of friction, right? So which means we need to expand this equation some more. Okay, so m2 gh initial plus. Now, in order to apply mu in our equation, we need to expand frictional force because we don't have frictional force also. Okay, but what we do have is mu n. So mu n as cos theta equals to 1 over 2 m1 v2 plus 1 over 2 m2 v squared, and then plus m2gh final. Now the next questions would be, I don't have n, right? But then I can calculate n. So if you look at block 1 is moving along the horizontal component. Okay, so the free body diagram for block 1 is like this. So for block, I have tensions going to the right, I have frictions going to the left, but then I have normal going up and I have weights going down. So velocity is going to the right. So which means there's no motions along the y component. Therefore, we can apply Newton's first law to determine the values of n. So summations Fy is equals to 0. Okay, so look at the bottom left. Yeah, I write it on the bottom left. And then, okay, and then the things that I have is n is equals to W. Okay, while that is equals to mg, which is equals to 9.81 times the g, sorry, the m is 3. Okay, so which is then equals to the block 327. You calculate it. I'm lazy to calculate it. Okay, so you calculate by yourself. So that is a 3 times 9.81. Okay, 3 times 9.81 for the
9.43.
berapa?
29.43.
0.43. Thank you very much. So 29.43 Newton. So now that I have the n, okay, and then I'm going to solve these questions. Okay, I will try to see if I have enough information to solve it. So m2 is 5 kg, and then 9.81, and then initial height is x, plus mu is 0.4 times n 29.43. Now how about s? It tells you object drops by 1.5 meter. Then definitely this block will move by 1.5 meter as well. All right. So 1.5 and then cos. Now it's energy loss. So cos 180 degree. Right? Cos 180 degree. And then it is equals to, I'm going to write next row. 1 over 2 m1 is 5, m1 is 3 kg. 3 kg v square plus 1 over 2 5 kg v square plus 5 9.81 x minus 1.5. Okay, x minus 1.5. So once you reach this step, basically you are done. Okay, basically you got the answer already. Why? Now, even though it seems like you have two unknown in these equations, one is v and one is x, but after you rearrange the questions, okay, after you rearrange it, okay, you should be able to reduce the unknown to 1. Okay, the x will be cancelled out. The x on the left-hand side and the x on the right-hand side, they can cancel out with each other. So eventually you will get v final. Okay, v is equals to 3.7 ms negative 1. So you try to solve it. Okay, you try to solve it. This one just involves simple mathematics. Wait, yeah, let me zoom. Okay, so involve just a simple mathematics. So I'll leave it to you. So basically, that is the complete answer. Okay, the complete answer for question 6, where it involved two objects. All right, so write it down, see whether you can answer it or not. And this one, actually, you have a one past year questions that also involve two objects which you can try. Okay, I think the question is coming from 2015, 2016. Okay, you also got the two objects there, so maybe you can try it out. All right, so this question is not hard if you understand the concept of a principle of conservation of energy. So the energy that we are looking at is not the energy for just one or two object, but the energy for the whole system. Okay, the energy in the whole system. Right, so yeah, you try to solve it. So if you have any questions, you may ask. If no, I think that's all for today. I'm not going to discuss the next subtopic with you yet, because I want to finish the next subtopic in one shot. So perhaps we'll do an extra class tomorrow, again from 11 to 1. Why? Because next week I'm not around again. Okay, so very unfortunately, this September I'm super busy. So I got a 3-day workshop again next week. So from Tuesday until Thursday, I'm not around. All right, so I'm going to have an extra class with you guys again tomorrow. Maybe just a 1 hour. Okay, I'm not going to do 2 hours tomorrow because I got some things to do. All right, so perhaps 1 hour tomorrow. I will finish next subtopic with you guys.